Hello, I'm Adam, and this is MetaQuest 3, and it has BOBOVR M3 mini head strap, and as we can see, this is a battery pack expansion port. So this is a place where you can put your battery, let's say power bank, to power your headset and have more playtime. And you can buy this BOBOVR battery dock, and this is a dock for this place. I need something to cut it. Okay. And that's how it looks. We've got whole kit. I must say it's pretty nice. Maybe the connector is from the very hard plastic made, but we've got braided cable, and we've got our power bank. There we go. Yeah, fully charged. Interesting. And it's mounted. Very strong magnet. Yeah, and you just need to and you've got even screws. Yeah, and you just unscrew the cover, you install this thing like this, and you can, yeah, and yeah, that's how it works. Let's focus on the power bank. This thing has 5200 milliamp hour battery. And let's measure the weight. Okay. And this thing weighs 140 grams. I don't count this because, but there is a cable. Maybe let's try in a dirty way without cable. Let's say 170 grams without cable. That's heavy. And that's heavy, and it's 5000 milliamp hour battery, so that's about the size of the Quest 3 battery. And I found a pretty nice way which could be cheaper, because this thing cost about $40, yeah, and so I found cheaper way, quicker way, ugliest way, but DIY way. So my proposition is those modules. I will open two different models. Okay, first one and second one. Okay, the idea is to build my own power bank. There we can see a thermistor in both modules. Okay, and that's how they look like. Both are very minimal versions with only single USB-C port, which is input and output. There is a USB-A version too. And those things, of course, the battery checking, there is a pretty big but nice display. There is a button, and we've got LEDs. That's how they work. What's going through into details about them? I've got pretty nice data sheets. Few things to mention. There are resistors, 2 and 3, there. And so if 2 and 3 is present, we've got 10,000 milliamp hour battery. If only 2, we've got 20,000. And if we've got only 3, we've got 30,000 milliamp hour battery. I have no idea why, but yeah, there is a setting. Okay, next, those are the dimensions. And about capabilities, As we can see, it supports, let's say, everything, with output power up to 22.5 watt. So that's very enough for Oculus Quest to be charged at full capacity without losing percentage or something. So I think that's very nice thing. And those modules require one lithium battery, and that's it. There is something mentioning that we need a cell with a capability of 10 amps, yeah, and non-fast charging 7 amps, but whatever, we need just good lithium battery. Okay, and now let's okay, and now if we remember 140 grams, we've got 6 gram module. We'll need a 3D printed mount for the headset. Close enough, yeah? Yeah, this is for the Velcro strap and that's it. So you just screw those there, even the holes are fitting. Yeah, so we add it like this. And now the fun part. What size of the battery we want? 5000 milliamp hour? There we go. 88 grams. So almost half of the weight, having almost same capacity. We want 10,000 amp hour? There we go. We've got 156 grams. Of course, we will add like nickel strap and maybe Velcro strap, but anyway, those will be just few grams. Currently, I will have 10,000 milliamp hour battery, power bank, which weighs 156. We should compare it to 170. So, rounding, we've got about same weight with the nickel strips, etc. But capacity is doubled. But that's not all. Of course, if we wanted lighter, there we go. But if we want super light, we could just add 18651 cell, and this is LG MJ1 3500 milliamp hour. That might be pretty low, but next, if we add another one, we'll got only 110 grams and 7000 milliamp hour battery. Yeah, even we could add another one, but now we are like 10,000 milliamp hour battery, but 157 grams. By the way, how it was with those? Oh, yeah, something around that. But this is much simpler build, and as we can see, we could just make this bank like this, or maybe from this side would be better to go around the headset. And of course, it should fit there. Yeah, that's how it should fit. It fits pretty nicely. And USB-C port. And yeah. So this is just quick video about just quick overview about capabilities of doing something DIY instead of buying pretty big and expensive power bank. Towards about grouping cells. Of course, those cells are let's say from the packaging batteries. Those probably has 0 cycles, and yeah, generally just as new, but maybe a little bit older. I'm using this kind of device. It was pretty expensive, to be honest, for a Chinese device. YR1035 Plus. This thing is capable of measuring the internal resistance of the battery using the AC method, because there are two methods for measuring internal resistance of the battery. One is when you put a load on the battery, you will see the voltage drop, you calculate it, and generally that's not a very reliable way to measure the internal resistance. And by the way, that's how the 18650 battery chargers are measuring, because they can put a load to the battery and now they see the voltage drop, whatever. So this thing is working on the AC, so it should be much it should has much better quality. And now, as we know, if I want to have a pair of cells, I need to select the closest one to the closest one, because if I do it wrong, so if I get the worst and the best that I've got, the worst will be quicker discharged. So the better would be more loaded, and even it can overheat. There will be more power consumption on the better cell, because the resistance is like there will be, for example, 14 milliohms, there, for example, 13 milliohms. So 1 milliohm difference in 10 amps is split on those, if we talk about 10 amps. So for example, in this can go a little bit higher than 5 amps, which should go for this one. So for example, this will have 4.7 amps and this will have 5.3 amps. Yeah, that's why it's very important to make them to group them very carefully. Okay, and now let's see their internal resistance. I will zero my meter, and yeah, so you can see that, yes. First one, 14.3. I will repeat the measurement. 14.4. Again, yeah, so 14.4, that's okay. Next we've got 13.4. okay, so I will I'm doing the order to worst to best just for myself. And next 14 again, 14.1. Oh, 14, okay, something around that. Next 14.2. I put it wrongly. 14.2, and this was the best probably. Yeah, so 14.3, 14.1, 14.3. Okay, so 14.2. Okay, so in this situation, for sure, we won't take the best one, which has 13.4. And now I've got 3 remaining. And 14.4, 14.1, and 14.2, I think. 0.3 again. 0.3. Okay, and there was a 2. So I will take those twos. So I've got the middle ones. So those will suit the best because those are very close. But in connecting cells in a parallel, we need to have exactly same voltage. So in this example I've got 3.57 volt, and there I've got 3.57 volt. So no problem, I can connect them using the spot welder, and it will be perfectly nice battery bank. Yeah, I will do same for the greens, etc. Okay, that's how it looks. Okay, that's how both modules looks, with the bigger battery and the smaller battery. Unfortunately, I didn't have plastic to bigger ones, but whatever. As we can see, I did two approaches there. First one is to just, if you don't have a special nickel strap, so just I cut the one line and soldered directly to this one. I think I didn't overheated the cells because it was pretty quick solder and it's not directly to the battery. I think it's still fine, yeah, because those are pure nickel, those solder pretty nicely, so I don't think this is a problem. But for some of you that may say you overheated the cells, I did like this. So I added additional strap and welded them, and yeah, so I was soldering there, so this part was, let's say, cold, way colder. My impressions on both, I would say this one is better because maybe you won't see, but those welds are working, and those can crack, to be honest, and I'm afraid of them. And yeah, so I would prefer doing like this. Okay, so as we can see, both power banks are showing the percentage and the state of charge by LEDs. I prefer the one with the display because yeah, it's way more accurate. But now let's check one thing. Does it support, for example, Samsung Quick Charge? And I've got there a Samsung original cable with Samsung power bank, and it's fully charged, and I connect phone, and now as we can see, fully charged, 44 minutes to be fully charged. Yeah, so it was the super fast charge, fastest that S21 can support. And yeah, now let's check if this one supports that even on 23% of the battery. And how does the plug? Yeah, it's fine. Oh, it's charging, and now we can see fast charge 29 minutes, and yeah, we can see percent down, so it's just fast charge for Samsung. And let's connect it to this another module, and yeah, same, it's just quick charge for Samsung. In this case 49 minutes to full, and in this case it said 44 minutes to full. Oh, what a difference! Whatever. Yeah, so as we can see, it's not it's not supporting the latest Samsung very fast charging technology, but anyway, it supports fast charging. And I think in the MetaQuest it's needed 2 amps 9 volts, so it's about quick charge 3. It supports it, so I think that's not problem. And if we press it, 25%, and second LED. To be honest, this one wins best. This one LED and nothing well. Okay, so let's quickly compare only the batteries. As we remember previously, it has 140 grams, and now the 7000 has 106, and the 10,000 capacity has 148. So maybe it's like about to be same, but it has the twice capacity as this one, and of course it looks like, oh my gosh, DIY it. I should 3D print a case for that, but whatever, maybe I'll do it later. But if we compare it with a adapter, I'm trying to do it without cable, so that's why the cable is lying on the desk. 23 instead 11, 10. Yeah. So, summarizing, I think I've got, oh, by the way, let's try to connect the BOBOVR and see what charging I will have. And same, fast charge, 28 minutes. Yeah, so, same, not the fastest charging on Samsung, but whatever. Okay, and that's it. Thanks for watching. Please leave a comment and hit the subscribe button. Bye.